Good morning, this is your captain speaking. Please keep all phones put away and on silent if you know eating in class, and if you have any questions or concerns, please ask your attendant. Thank you for flying Integrated Math Airlines, and happy mathing.
Hey guys, Mr. Eng here. Let's go over the Module 4 test, May 21st, 2025, version B. Question number 1. So for the first 3 questions, suppose the functions g and h are defined for all real numbers x as follows. G of x is x minus 6. And h of x is 2x minus 2. They're asking us to subtract, but if you subtract, remember it's like distributing the negative. So that'll become negative 2x squared. And then you can just put those in order. X is positive, and then this would be choice C. Okay, so then I want you to notice on this one that this is a closed, so that means it's a multiplication, not composite functions. So all you have to do is just multiply the two. So I have g of x, which is x minus 6, and then h is 2x squared. Now if that looks funny, you can put that in the front, so you have 2x squared, x minus 6, and then you can just distribute 2x to the third minus 12x squared. That one will be choice C. Question number 3, I want you to observe that this is now an open. That means g of h of x. And he wants to put in negative 3. So you're going to put in negative 3 into h. So let's go ahead and do that. H of negative 3. H is 2 times negative 3 squared. So every x value is becoming negative 3. Negative 3 squared is 9, so then I have 18. So this is all becoming 18. So you have now need to find g of 18. So g is x minus 6. So now it'll become 18 minus 6, which is 12. G of 18 equals 12. And then we choice A. Question number 4. So I need to start off at negative 4. Now, you have a couple of choices. You might see a negative 4 here and there, but we're looking for x values. So I'm going to start here. I have an output of 0. Now the output becomes the input at f. So we go up to f, look at 0, and it does become negative 2. So we started at g, start, and remember going right to left. So then my answer is going to be A. Question number 5, which of the following is equivalent to y to the 7 halves? So y 7 halves, we have that silly phrase for the fraction, top, bottom, and for the radical, it's in, out. Okay, so we're going to here, this is the top, so it's going to go on the inside. And then this is the bottom, so that's going to go on the outside. Okay, so let's think. It's not going to be this one because that's essentially like this. Oops, that should be a y. So it'll be like y to the 1/7 plus 1/7, which would give us y to the 2/7. That we know because we went 7/2. Okay, so let's try B. Now that one has a 2, so that inside will become, remember that inside is the top, and then you have the power rule, so you can multiply across, you'll get 7/2. So I like that one. But let's double check this C. Whoops. Let's see. Let's use this color. Yeah, this one can also be the answer. So you can have either B or C to have the correct answer. Number 6. Do the same thing. So in the top goes in and the bottom goes out, and that would be choice B. Okay, which graph can you take the inverse? So to do that, you'll first have to become a function, and to be a function you have to pass the vertical line test. So in pink, this one does not pass the vertical line test. This one does, right? Goes through 1 point, that one goes through 2, passes. Okay, now to take the inverse, it's gonna have to pass the horizontal line test. So this one's already out. This one's gonna fail. That one's also gonna fail, but that one's gonna pass. So only one with 2 check marks there is D. So D is our correct answer. Let's go to the back side. Okay, which one is not equivalent to x to the 1/3? Okay, so let's try A. So remember, top goes in, so this would be x to the 3/1. So I'm already thinking the answer is A, but let's double check. Let's try B. So x to the 1/9 to the 3rd power. Okay, this is power to a power, so you just do multiplication. X to the 1/9, you can make that a fraction, 3/1. Multiply across, you're gonna get 3/9, and that'll give you 1/3. Okay, let's try another one. D, x to the 1 times x to the -2/3. Okay, we can make this a fraction and multiply by 3/3. So that'll become x to the 3/3 minus 2/3. You just subtract the numerators, and then you will get x to the 1/3. And then the last one, E. Okay, first I'm going to convert it, so I get x to the 1/6. And then I can just multiply, because it's a power rule, 2/6, which is 1/3. Okay, so notice, let's get another color here. So all of these are 1/3. 1/3, 1/3, 1/3. This is the only one that's not 1/3. So we're looking for the not. So that would be choice A. Okay, number 9. You're given these 2 functions, and basically what we have to do is we have to test 2 things. I want to know if this equals to an x. Okay, so let's put an f first. F of x equals x minus 3/2. Then every x value we're putting in g. And instead of g, we're going to write 2x minus 3. And all we have to do here is just simplify. So I'm going to get 2x minus 6/2. If I factor out a GCF, I get 2. And then your 2's would cancel, so you're left with x minus 3. So that's bad. Right, we're trying to look for x. Let's do it the other way around now. Let's do g of f of x. So my hint is to write g first. Then every x value is going to become f. Okay, so let's write in now f. So that'll be x minus 3 over 2 minus 3. Okay, so you put it over 1, you could distribute, but those will cancel. So you're left with x minus 3, which gives you x minus 6. Okay, so you'll notice that both of these are not equal to an x. So the answer is B. They are not inverses. Okay, let's go over question number 10. Perform the indicated operation. I want you to notice that this is an open circle. So this is not multiplication. Because if it was multiplication, it would be closed. Right? It would look something like g times h to the n. Okay, so basically what this is called composite functions. And if you think about it, if you went back to something like this, g gof of x, it would essentially be the f of x is going to go into g. Okay, so let's go ahead and do that. I'm going to have g, and you're going to put in h of n. Okay, so let's do h of n is in green. So let's do blue for g. Let's write that. G of n equals 3n squared minus n. Now this green here, we're going to put in for every n value. So let's just put in h there. H of n equals 3 times h of n. H of n. Now the h of n we'll just use from over here, right? N minus 4. N minus 4. N minus 4. So I have g, we're going to put n minus 4, which we just did, squared minus this. Okay, so here, again, you're not going to multiply first. Let's just write that out. You're going to do PEMDAS to simplify. So we're going to do parentheses first, which would be this. So really, that's n minus 4 times n minus 4. Let's go ahead and do that. Let's do that over here. So n squared minus 4n minus 4n plus 16. So you will get n squared minus 8n plus 16. And then we still have the 3 there. Okay, over here, you can distribute this negative 1. So that become negative 1n, and then it'll become positive 4. This one we're going to have to distribute. So let's distribute the 3. So 3n squared minus 24n plus 48 minus 1n plus 4. And then we can just combine like terms. So 3n squared minus 25n and then plus 52.
Math is the best. Math is the best. Math is life. Mr. Eng, the best teacher in the West. We're so blessed to have Mr. Eng. Praise Jesus.